Hello. Today we're going to continue our conversation around perpendicular lines and how we come up with the equations of those perpendicular lines. So our objectives today are students will be able to determine if two segments are perpendicular, and students will be able to write the equation of a line perpendicular to a provided line. The if two segments are perpendicular is a conversation around the slopes, and then the line part is part of what more of our focus today. Okay, so first I have talked about slope-intercept form and point-slope form, and I mentioned that we have a third form of a line, which is standard form, but we haven't really worked with it much. So we're going to learn how to rewrite equations from standard form to slope-intercept form. And it's not that standard form doesn't have uses, it's just that for what we're doing right now, slope-intercept form is a much more convenient form of a line. So just to be clear, standard form is really great at looking at intercepts, x-intercepts or y-intercepts. And the reason is because you can simply substitute. If I want to have the y-intercept, I substitute in 0 for the x, and I can then solve for the y. And if I want the x-intercept, I can put 0 in for the y, and I can get the x-intercept. And those details are important as we go through equations. But simply, when they want us to rewrite these, it's that we want to solve for the variable y to get it in the form y equals mx plus b. So as I would go through this slope-intercept form, just as a reminder, y equals mx plus b. Notice how the y is all alone. And then from there we can state the slope and the y-intercept. So the first thing, and what's nice about this, is I'm not actually going to combine anything because they're unlike terms. So a reminder, vocabulary would be unlike terms. We're going to subtract the 4x from the 2y because ultimately that's what I have to isolate. And so I get 2y is equal to negative 4x plus 10 because it was a positive 10. And then I divide both sides by 2. And I have to divide the whole entire right-hand side and the whole entire left-hand side. And so that's one of those struggling points that students tend to miss, is that I'm doing the whole entire thing. Now, as a review of how this works, there's a 1. The denominator actually goes to both terms. And so the negative 4x divided by 2 plus 10 divided by 2 is how you should be going through the division. And so y is equal to negative 2x plus 5. If I want to know the slope is equal to negative 2. You might want to put the over 1 in there just as a reminder that it's a ratio of rise over run, and the y-intercept is equal to 5. The next one is the same process, negative 3x minus 3x. There makes a 0. So now I have 9y equals negative 3x plus 27. Divide those sides by 9, the whole entire thing. So y is equal to negative 3x divided by 9 plus 27 divided by 9. Y is equal to negative 1/3 x plus 3. And so, yes, you can have a fraction. So your slope is equal to negative 1/3, and your y-intercept is equal to 3. The last equation, same process, negative 3x, negative 3x. So the minus 5. Notice how that came down. Now, that's another area that I would say is a troubling one for many math students, in that they lose track of this minus sign. And so the minus sign comes with the term and really becomes like a plus negative 5y. So negative 3x minus 9. Divide both sides by negative 5. Y is equal to negative 3x divided by negative 5 and minus 9. So really this should plus a negative divided by negative 5, just to kind of keep it in a more represented simplifiable method. And so this is 3/5 x plus 9/5. Notice how they turned out positive, so my slope is 3/5. And my y-intercept, it's okay that the y-intercept is a fraction, because in life a lot of the numbers that we deal with are not just simple, easy to deal with numbers. I mean, think about your gas when you go buy it at a gas station. It's never just like $3 or $2. And so we're going to continue this. It says given A is 4, -5 and B is 8, 3. Find an equation for the line through AB perpendicular to AB. And so it's really important that you highlight these words when they say perpendicular. And the reason why is because perpendiculars have negative reciprocal slopes. And so what this indicates to me is the first thing I really need to do is figure out the slope of AB. So just put AB so I remember what I'm working with. And reminder of the equation, it's y2 minus y1, x2 minus x1. So 3 minus a -5. I want to make sure you understand that part. It's really important that you understand that your y2 is the -5. The equation started out with a minus sign though in it. So this minus sign is the minus from the formula, and this is the negative sign from the actual point. Over 8 minus 4. So this gives me positive 8 over 4, which is equal to 2. So as I'm looking at that, I might be wondering how I can turn that into a negative reciprocal. Well, I also have to remember that that is over 1. And so I like to make sure I identify the perpendicular. I always write what that means. It means it's a negative reciprocal. And then I can work with the slope. Now that I've listed this out, it says find equation through A perpendicular to AB. We have two forms of lines that work well with this. I'm going to do point slope formula, so y minus y1 equals m times the quantity x minus x1. My slope is -2, or -1/2, sorry. The point that they asked me to go through was through A, and so I'm going to substitute in there the 4 and the -5. So y minus -5 equals x minus 4, y plus 5 equals -1/2 x minus plus 2. Subtract the 5, subtract the 5, y equals -1/2 x minus 3. Okay. Again, find an equation or line through B and perpendicular to AB. I always write this down. Perpendicular is a negative reciprocal. Since I'm working from the previous information, it's just a -1/2. I'll show you how to use y equals mx plus b at the point that said b, so b is 8, 3. What this tells me over here is that x is equal to 8 and y is equal to 3. And I can use those back in here. So now I have my m, my x, and my y. So 3 equals m is -1/2 times x, which is 8, plus b. 3 equals -4 plus b, and then 7 is equal to b. So my equation in the end will be y equals -1/2 x plus 7. Okay. The last problems that I want to go over are very, very similar. I used the exact same numbers so that we could sort of make connections. It says find the equation through 3, 2 parallel to AB. And so this says parallel. We know parallel means equal slopes. And so what I need to do is make sure I calculate this slope. These numbers are from the previous problem. Where we know the slope equaled 2. And so if it's an equal slope, that means the slope m is going to be equal to 2 also. Since I want to go through the point 3, 2, that gives me my x and my y value. So in one situation, I'll do the point slope formula line, and the other one I'll do slope intercept. So here we go, y minus y1 equals m times x minus x1. Y minus 3 equals my slope 2 times x minus 2 over here, sorry, and 3. Y minus 2 equals 2x minus 6, add 2 to both sides. Y equals 2x minus 4. Again, just make sure, might help you to put the x and the y in here. This was a 2, not a 3. Last problem says equation parallel. Again, I always write out exactly what that means, which is equal slope. So m is equal to 2. I'll do y equals mx plus b this time at negative 4, 3, x, y. So x equals negative 4, y equals positive 3. Make the substitution 3 equals 2 times x, which is negative 4, plus b. 3 equals negative 8 plus b. That's 11 equals b. And so my final equation, y equals 2x plus 11. Okay, really important takeaways from today are the annotations for either parallel or perpendicular, and making sure we understand the relationship to the slope. And the other thing is to make sure that you understand how to solve a standard form equation into y equals mx plus b. Thank you.